Hello everyone. In this video, I am going to show you chapter 9, section 9.1, center of gravity, center of mass, and the centroid of the body. The body is composed of an infinite number of particles. So if the body is located within the gravitational field, meaning if there's on Earth, then each of these particles will have a weight dw. Every single one of the particle, every single tiny little piece of it will have a weight dw. Center of gravity, CG, is a point, often shown as G, which located the resultant weight of the system of a particle or a solid body. From the definition of a resultant force, the sum of moments due to the individual particle weight about any point is the same as the moment due to the resultant weight located at G. Also, note that the sum of a moment due to the individual particle's weight about point G is equal to 0. General equation, you got to remember, we have x bar, y bar, z bar. If this thing we're looking at is in 3D, x bar would equal to integral x bar dw divided by integral dw. Similar, we'll do the y and the z. Y bar will equal to integral y bar dw divided by integral dw. And then also the z bar will equal to integral z bar dw over integral dw. I will show you some examples in a little bit. But centroid C is a point defining the geometric center of an object. Centroid, one more time, is the geometric center of the object. Centroid and the center of gravity will be the same point only if the material of the body is homogeneous. So in other words, if the entire body is made of the same material, same density, then centroid and center of gravity becomes the same point. So here shows you the steps on how to determine the centroid of an area. Basically, we're going to choose an appropriate differential element dA. Sometimes it will be vertical strip, sometimes it will be horizontal strip. I will show you an example of each type. And then we're going to express the dA, this strip, in terms of the differential element dx or dy. And then we're going to determine the coordinate x bar, y bar of the centroid of the rectangular element in terms of the general point x and y. And then express all the variable integral limits in the formula using either x or y depending on the on whether the differential element is in terms of dx or dy. So this one right here, given the areas shown shaded and shown in the diagram, shown in the graph, we're looking for the centroid of this blue diagram, the blue part. We're going to look for the location of the centroid x bar, y bar. So first, this problem right here, we are going to pick a vertical strip. So the red vertical strip that we're looking at, dA equals y dx, y being the how tall this red strip is, and then the dx being, horizontally, we have a very small element dx. Putting that together, since your y equals x cubed based on what was written in the diagram, so we have x cubed dx. And then the rest of them will just be your calculus. Putting that together, we get the value of x bar and value of y bar. That would be the centroid of the blue geometric shape here. This example number 2 right here, we are going to do horizontal strip. So dA is equal to x dy, x being the actual length of the darker blue horizontal strip. And then the dy being a very small element along the y direction. That's why we have a horizontal strip. And then since based on the what was written on the diagram, y squared equals x, that means we're going to plug it in for the value of x. So you have y squared dy. And then be careful with the x value that you plug it in over here. So the x value that we put on here is the length from here to here. Actually, refers to the width of the darker blue horizontal strip. That is the x that we're referring to. But the actual value of that x value will be the total length, which is 1 meter right here, which is 1 meter minus the coordinate of this point right here. So in other words, 1 minus however much that we have over from here to here. Okay, that gives you the from there to there is the actual coordinate of this point right here. Okay, so 1 minus the coordinate of this red dot here gives you the width of that darker blue horizontal strip. So be careful with what x value that we plug in there. The rest of them, it will just be plug it in as as in your calculus class. This problem right here, we're looking for the location of the center of mass. Since this plate has a uniform density is all the same throughout the entire thing. So the center of mass will just be the same as the centroid of this geometric shape. We know that this thing is 0.3 meters. So first, we're gonna pick a vertical strip. Now the vertical, so how tall this thing is, the height. Yeah, that's the word I was looking for. The height of this vertical strip, it will be y2 minus y1. Okay, so the orange part that I do, that I highlighted here, it will be the value of y2 minus the value of y1 gives you the height of this vertical strip. And then horizontally, you have a dA. And we know the y value, the top one, y squared equals 2x. That's why you will have square root of 2x plus x, because the one at the bottom is y equals negative x, right? So we put that together. This square root, yeah, y2 minus y1, square root of 2x. The square root should stop discontinue right here. It does not include that plus x. It will look like the one at the bottom right here, but it will be plus. That's a typo, another typo right there. It would look like square root of 2x only plus x, okay? Because we have the one on the top is y squared equals 2x. That means y equals square root of 2x. And the one on the bottom is negative x, so top minus bottom. That gives you the height of this orange part. And then horizontally, you have your dx. And sorry, this thing is printed out funny on the in the PowerPoint, but Rodity is calculus, putting that together to get the actual value of x bar and the value of y bar. Once we figure out the location of the centroid, center of gravity of this plate, and we know the location of it, and we'll place the weight of the plate at the centroid G, and we use this total area, and then multiply by the horizontal and vertical moment arm using the free body diagram to find the reaction force at location A and location B, the pin support at A and the roller support at B. This is all I want to show you in 9.1. Thank you for watching.